For the Michelson-Morley experiment, as we said before, the total traveled distance of each arm of the interferometer, 2L, was equal to 22 meters. And the wavelength that they used in their experiment was 550 nanometers, which gives a period for the light wave, for that wavelength, of 1.8 times 10 to the minus 15 seconds. Here we have used the generic expression that the speed of a wave times its period is equal to its wavelength, and we have plugged in the current known speed of light, which is about 3 times 10 to the 8th meters per second. Okay, so remember, after rotating their interferometer by 90 degrees, what Michelson and Morley were measuring was the quantity 2 times delta t, the difference delta t, the difference in the travel times in the different arms of the interferometer, and using the expression on the previous view graph, that's equal to 2 times the interferometer arm length L divided by C times over C times beta squared. Okay, so if we plug in numbers for this, okay, then this is that's the velocity of the Earth through the okay, here I've just written it out. So this, if you just basically, I just plugged in numbers for into this expression, and this is roughly 7 times 10 to the minus 16 seconds. Okay, and so if you compare this, okay, to the period, all right, then what you get is 10 to the minus 15 seconds. What you get is about 0.4 fringes. Remember, a t over 2 time difference implied a 1/2 fringe, oh man, 1/2 fringe separation, or fringe shift, sorry. Okay, so they expected to see 0.4 fringes of shift after they rotated their apparatus by 90 degrees. All right, and it turns out that Michelson and Morley, although they expected to see 0.4 fringes of shift, they saw nothing. They saw something which was consistent with 0. And let me also point out that the precision of their instrument was much better than 0.4 fringes. So their result was completely inconsistent with what they were expecting. If the velocity of the Earth through the ether was 30 kilometers per second, that is, if the ether was stationary with respect to the Sun and the Earth was moving through it at its normal orbital velocity. So Michelson and Morley concluded from this experiment that something was wrong with the standard ether theory. Okay, but they and others were pretty hesitant to give up on the ether theory, and they proposed a number of different things. For example, perhaps the Earth had a sort of an atmosphere of ether that it would drag along with it as it moved around, as it orbited around the Sun. But ultimately Einstein came up with a different explanation. Einstein's theory was that maybe there was no ether, since we can't observe any effect of the ether, and further that the speed of light was the same for all observers and in all different directions. And his theory eventually won out and is still the accepted theory today after many rigorous tests.